So, one of the things I love to do is to take science from science fiction and just wonder what would happen if it was taken in the real world. Would it work or the whole thing just fail? I've been watching an anime called Toaru Kagaku no Railgun, and in the anime, there's a girl named Misaka Mikoto, nicknamed the Railgun. She's able to control 1 billion volts to fire arcade coins at muzzle velocities of 1030 meters per second, which is pretty cool. So how does this work in real life? Are railguns just things found in video games, or is there actual legit science behind the fiction? In order to really understand railguns, we have to understand magnetic fields and how they can relate to electric currents. Huh? You might ask. Weren't we talking about electricity and how it can use to fire bullets at super high speeds? Yes and no. Yeah, we use electricity, but that's not the main force at work here. In fact, all the force used to push out the bullet is magnetic force. It was discovered that when you put a current through a wire, a magnetic field is generated around the wire. A field is an area of space that tells you if you put a moving electric charge, how big and in what direction would a magnetic force act upon that electric charge. The direction is pretty easy. We use something called the right hand curl rule. Simply use your right hand to grip the wire with your thumb pointing out in the direction of the current. The direction that your fingers curl in is the direction of the field. The strength is a little harder. We use something called Ampere's law, coined after Andre Marie Ampere. Ampere's law states that the integral loop of B dot ds is equal to mu times enclosed current. Basically, we do a little calculus, and we find that for a straight wire, the strength of the magnetic field is mu naught times I divided by 2 pi r, where mu naught is a constant and r is how far away you are from the wire. Now that we have the strength of the magnetic field, just how big of a force would be exerted on a moving electric charge? Well, it has been determined that the force is Q cross VB, where Q is the electric charge, V is the velocity, and B is the strength of the field. Because it's a cross product, we can use the right hand rule normal to determine the direction of the magnetic force. Simply face your palm in the direction of the field, and point your fingers in the direction of velocity. Your stuck out thumb will point in the direction of the force. But back to the topic at hand. We're dealing with currents in wires, not just single charges. That means possibly even billions of charges, all flowing through the wire. We want to convert that equation we found earlier into a form that can be used for currents. This requires a little bit of algebra and logic. Since current is defined as how much charge flows past a point in a set amount of time, we can rewrite that as Q is equal to IT. All of the charges are moving at a drift speed of v, and finish moving across the wire at a time t is equal to L divided by v. So, substituting, we find that Q is equal to I times L divided by v. Substituting Q into our original equation, we get the formula F is equal to B cross IL, which we can use for currents in wires. Now, time to put everything all together. A railgun is actually quite simple in concept. We put two conducting rails, and between that a conducting fuse and a projectile. We then run an insane amount of current through the rails, like so. The current is actually so strong the fuse melts and vaporizes. Using the right hand rule curl and Ampere's law, we can find the direction and strength of the magnetic field produced by the two rails. Plugging it into the equation F equal to B cross IL, and we see that the force actually points outward. This force is going to act on the conducting gas, and the gas in turn pushes the bullet outwards. Notice that we're still running current through the gas, and because gases are essentially very tiny particles, there is a dust explosion effect. The result is a moving flume of explosions behind the bullet. So actual railguns are able to shoot at speeds of Mach 7 to Mach 16, all of which are considerably faster than Mikasa's muzzle velocity, around Mach 3. The only redeeming quality of Mikasa's railgun is that every shot of hers only costs a single arcade coin, and maybe a good night's sleep to charge up her ability. However, a railgun bullet costs around $25,000. Conclusion? Why talk about the science in fiction when the science in reality is even more destructive?